We got some requests last week for some basic meshing questions in Femap, how you do things. I guess lately we've done a lot of emphasis on geometry and geometry cleanup and automatic meshing, but just want to do a quick video here, just back to some of the basics. Just sitting here in Femap 11.2, and just to get going, let's create a new empty just material, new empty model here, and I'll just load a material from the library. And what we'll do here is let's create a couple of properties. So I'll say new, and we'll just do a shell mesh. We'll make that the thickness, and pick that aluminum we just made. Then let's also create some beams. We're going to do a little stiffened pressure vessel here. So let's change this to a beam, and then let's go with the shape. We'll do a little Z-shaped stiffener. It's asking for a height. Let's do 1.5, a width 1, width of the bottom 1. Let's just make them 0.5. Yeah, a little thin here. So let's it looks a little better. And let's just make the top a little thinner here. There we go. And I'm going to use the y-axis up for later on when I'm orienting my beams. I'll remember that. That's the up direction. And the reference point, that looks good. I want it right. Well, actually, let's move it to the center of that bottom piece here. Oh, there it is. So now when I'm putting my nodes, that'll be where the nodes kind of ride on the cross section. So we'll say Z stiffener, and that's it for creating properties. And I didn't name my plate here, so I'm just going to rename it real quick here and say shell. So my thin shells. Now some basic meshing commands in Femap, and this is from back in the DOS days, version 3. This is kind of the only way Femap can mesh back then before geometry, but we had a mesh command called generate between. So it's mesh between, and it's basically two corners will do beams, and then you can do four corners to do plates. So I switch to a plate property, and it knows I'm doing four corners, but you can also do it in any coordinate system you want. So I'm going to do it in a cylindrical system, and let's just put 3 nodes going radially around, and then we'll do, let's just say 12 nodes up. So now it's asking me for a radius, and I'll just start at a theta equals an R of 12, theta 0, Z of 0. Then we'll go to 45 degrees, and then we'll go up in Z to 24, then back to 0. And you can see that in a cylindrical system, that's kind of just a little part of a cylindrical mesh. Now, kind of the beams, we could do a generate between and go between here and there. So let's just do that. We'll do the same number of nodes, or you know what? Let's just generate these manually. So I'm going to switch my property to beams. And I'm going to tell it, I am generating beams. And remember that y-axis, so I'm going to align the y-axis of that cross section with this axis. And just say 0, 0, 0, 1, 0, 0. And just preview that. So that'll be my alignment of my beam cross section. So now I'm just going to pick 2 nodes at a time. And anyone new to Femap, you can, if you pick, it fills in the 2 nodes, you can hit OK. But if I double click on the second one, it presses the OK for me, so you don't have to be bouncing back and forth down to the that dialog box. So I can lay my beams down like this, and there's my beams. Now some other, just to visualize a little more, let's turn on some thicknesses and such. So there's that beam cross section, and just to get them, it put the nose right at the neutral axis. Let's move them down to the reference points. We have modify, update elements, and it's the line element offsets. And I can select all. It'll throw out the plate elements because it knows it can't do that with them. And I'll say move to reference point. You'll see it moves them right now. So now the nodes are writing exactly on that one section, and the plates are kind of faceted a little bit there. So one thing I think I will do here, and another manual meshing command in Femap, is I really want some more plates than this. So we have this nice mesh editing command called um, edge split. You basically just pick two nodes, and Femap splits it and drives that all the way through the mesh. And the real neat thing is in a connected mesh like this, it would actually do it, all the way through and split the beams and stuff as well. But I don't want to do that last one, so I'm just going to undo there. Uh, to get rid of this faceting, another manual meshing type command will be modify move to node. I'm just going to select all my nodes, and then back in that cylindrical system, so I want to update the radial value to 12, and I'm not going to update the theta in the other one, so I can just leave that. You'll see it move them all exactly to there. And another manual meshing command, we'll finish off the cylinder, so let's do a mesh rotate elements, and we're just going to select everybody. And then that was 45 degrees, so I need 7 more. A little typing issue there. 7 more copies of that, and I'm just going to go back to a global coordinate system and say from 0, 0, 0, 0, 0, 1, that's the axis I want to rotate about 45 degrees 7 times. So now I've made a mesh of most of this part. And again, when you're manual meshing, one thing you might want to do is also check your coincident nodes and see if anybody needs to be merged. So I'll hit the preview here. It'll show me the nodes that are going to be merged. You can show the IDs of the ones that are going to be kept, the ones that will be merged away. And you can actually play some games with those IDs if you want to keep certain node IDs. We're just going to let it merge and keep anything. But that's some quick manual meshing techniques. But let's go ahead and keep going here. Let's say this top piece gets connected in with some tubes to the middle. So manual meshing wise, let's just go make a simple node. And there's a between method in Femap, and I can change my snap mode to node. So I can go between that node and across the way here to this one, and I'll preview and see that, yep, that's where I want it. So I got a node in the middle. So let's go ahead and just create kind of a little spider of beams to that. So I'm going to go just do generate between again. And I'm going to create a new property. This one, let's just do a little tube. So circular tube, and let's do 1/2 inch. And then we can point that up too. Say OK. And it's the same material, say OK. Fills it in automatically, and we'll do 11 nodes. And what we'll do is say OK, and we want to go from right there, which is the bottom of my little Z stiffener. I'm on this between, so now we want to go right from there and say OK, and then to the new node. And then we're going to align that thing with the global Z axis just to get the tube. I guess it wouldn't really matter, but there's a manually created little tube here, and we'll do the same thing we did before, but this time let's do we're doing a rotate again, I guess. Mesh rotate elements, and I can pick by property and get just my little tube guys there. And if I say more and go back to ID, you'll see it goes and finds all the elements made of that property. I say OK. We're going to do our 7 again, and against the same global Z axis and 45 degrees. And there's my tubes in there. Again, a coincident node check's probably a good idea. And we'll just select all the nodes, feed them in, and see that yes, those little ends in the middle are coincident. So let's merge them together. Now everything's connected. So what we could do now is if I want to put that same thing at the bottom, we'll just do a mesh copy elements, and I could pick them by ID, but I know they're all that property, so I'll just go and pick them, and you'll see it finds 80, and it wants to know how to copy them. We'll just say, let's just go right down from that node to that node at the bottom, and that should be all lined up. So we'll just do another check here. Coincident nodes, because those will need to be merged down at the bottom. So there's those. Say OK. They're now merged. Now another thing you might do, let's say there's a little type of stiffener, a little web in here, Let's just do some more manual mesh generation. It'll be easier if I get rid of the shrink to do this, or get rid of the thickness and cross sections. Let's just go in and throw some plates in. We'll just use that same property. There's a manual element creation that I can just say I want to create plates and connect it to that same property we're using for the side pieces. And let's just create triangle plates here. And this is just picking nodes. So we'll jump around here. And I am trying to pick them in the same order each time just to keep the normals consistent, which is sometimes important. No, don't want to do that. Must have typed in a bad number there. Boom, boom, boom. And we'll do some quads out here. So the same thing. And we could obviously, just like we did before, create the first one and rotate it around, but I want to roll now clicking, so might as well keep going. Oop, didn't pick one more. There we go. And we've got those in. And let's just do the same thing again. Let's just throw this down to the bottom as well. So I will do a mesh copy element. And here, let's just, another thing I'll show you here, kind of a handy tool. We could turn off a couple of the element types. This way I can just pick these, and then I can turn them back on for using the nodes to copy down. So we'll do the same thing we did before and copy them down there. So kind of some manual meshing, copying, moving, rotating, all those type things you can do with meshes. One final coincident node check. We'll throw everybody in, and yes, obviously there are some coincident nodes. We'll merge them. And just for fun now, let's go ahead and we'll just hold this down here. Let's just create a new empty constraint set. And just call it fixed at base. And just pick that one node and completely fix him. And then let's just, we'll do a modal run here, just shake this guy. So I'll say model analysis. Create a new analysis set, and this one I want modal. By default, Femap will set up a Nastran 1. It'll grab that one constraint set and hook it in as the constraint. It'll ask for 10 modes. If you're a Nastran person, you want to look in there and see what actually is really happening. Here's your actual Nastran input file that will get generated, and you see the constraints, the beam properties, everything we put in there. So this thing's ready to go. I'll hit analyze. Looks like it ran pretty quick there. Wow. So let me just go look at the results. Let me turn off the shrink. That was nice. We were picking those nodes, but now we'll just go full here. And just to see kind of what happened here, here's my results. I got first mode, and I got two matching modes. It kind of makes sense in a symmetric structure. So we got kind of like a first beam bending mode that way and matching mode the other way. And get into a little torsional mode there, axial mode, and then we get some second order type modes around the shells. So you can pretty easily quickly set up an analysis. And just for fun here, let's I'm going to stop that animation. I'm going to delete the results, and let's just see what you could do here to kind of play with the design a little bit there. So we saw those modes. Let's see if we can change them by just changing one of the stiffeners. So if I can edit this stiffener, I'm going to change his shape and just make him a little taller. So the height 2.5. And then just take a look at the shape. Yep, there he is. Say OK. You'll see that he gets taller out there. So let's just reanalyze. And we'll stiffen that guy up a little bit. So we go back to the results. You'll see the modes changed a little bit. Not a lot though. I guess that didn't really change that mode a whole bunch. They're certainly different. But that's kind of the manual meshing, mesh editing, copying, rotating things you can do with Femap and Femap with NX Nastran.